Tree comparison plays a critical role in gaining insights from hierarchical data. It includes structural comparison and node value comparison. Comparison among a few trees can be achieved based on the traditional tree visualization. Unfortunately, as the number of trees being compared grows, this method does not work. There are no techniques that support the comparisons of dozens or even hundreds of trees. We propose BarcodeTree, a novel tree visualization technique for comparing hierarchical structure and node attribute values over multiple trees. Our approach draws each tree with a single row using a style similar to a barcode. It maps the nodes to parallel bars in depth-first traversal order to preserve the hierarchical structure. It is critical for the linearized representation to preserve the hierarchical structure information and node value information. Therefore, we encode this information to parallel bars and get two designs of BarcodeTree. For the hierarchical structure information, the node depth can be encoded into the width to get BarcodeTree width, or height to get BarcodeTree height. And for encoding the node value information, BarcodeTree width can encode the node value to the height and color. BarcodeTree height can encode the node value to color only. With the matching nodes aligned horizontally, multiple barcode trees can be stacked vertically and viewed simultaneously for comparison. More importantly, BarcodeTree can be scalable for comparing structure node value amongst hundreds of trees. To aid the user in understanding the hierarchical structure of BarcodeTree, the structural cues are added on the bottom of the nodes in BarcodeTree. Users can double-click the root node of the subtree to collapse the subtree and summarize this subtree through a triangular preview. They can double-click the root node again to expand the collapsed subtrees. Users can compare the whole tree and adjust the aligned levels of the barcode tree. Users are able to select the subtrees of interest and make comparisons for only these subtrees. Additionally, they can also adjust the aligned level in this subtree interactively. The unaligned part of the barcode tree can be collapsed using glyphs with diagonal stripe textures. The density of the diagonal stripe indicates the node numbers of the compressed parts. The juxtaposed barcode trees can be sorted ascending or descending according to different criteria. For example, the node number, attribute values, and the original sequence of the data. We conducted a controlled user experiment to demonstrate the efficiency of BarcodeTree. The experiment compares 4 techniques with 4 tasks. Users are required to fill in their name and settings before the experiment. The first task is to find a descendant node. One node in the tree is highlighted, and users are required to find the second child of its second child, then click this node to finish the task. The second task is to find the nearest common ancestor. 2 nodes in the tree are highlighted, and users need to find their common ancestor and click it. The third task is tree comparison without scrolling. 3 trees are displayed within the screen space, and users are required to find the tree which contains the largest number of identical nodes to the reference tree. The fourth task is the same as task 3, except that users need to compare 6 trees, and only 3 trees are visible at a time, so the task requires users to scroll vertically. After finishing all the tasks, we collected the statistics of all the trials as support for our further analysis. The following case studies are based on the book Borrowing Records dataset. The first case is about the topology variation patterns. We brushed 2 corresponding periods in 2 semesters, Session A and Session B, and then fitting the selected trees within the screen space, we then select the language book category and align them. We also adjust the aligned levels to the 3rd level. To avoid distractions, we replace the other parts of the glyphs with diagonal stripe textures. In the focused result, the top part is the first period and the bottom part is the second period. Comparing these two periods, we can learn that the English and Old English categories have similar variation patterns, but the variation patterns of the linguistic category and Hellenic language category are different. Specifically, Session A has periodic patterns, but Session B only has a few random borrowing records. The following demonstration is based on a dataset of books borrowed from the library across 3 semesters. We brush the spring semester dataset with the mouse and then click on the first date in the semester as the benchmark. We then align the second level of the data to produce the comparison. As can be seen, the data is now aligned. We fit the data to the screen horizontally for ease of display. Then, we fill in the color to illustrate the actual node values. Finally, we examine the ratio of books from 0.35 to 1 based on how much they are being borrowed. Over the spring period, we have highlighted the overall books borrowed from both the social sciences and technology fields. As you can see, the values are roughly equal. Moving on, we are going to repeat the process now with the autumn semester. First, we brush over the relevant points, and again we are aligning the graph, adjusting the screen, and filling with color and filtering by ratio. We're checking on the categories by the ratio of book borrowing. So all of this is very similar to the spring period, with social sciences and technology again having a high rate of borrowing that is about equal. Finally, we brush over the summer semester and follow the same activities of aligning, fitting the screen, and filling with color, and then examining the borrowing ratio. As can be seen this time, there is more borrowing of books related to social sciences than technology. This is due to the different courses offered over the summer semester, with the pattern now being clear in the visualization. Despite the size of the dataset, however, it is easy to recognize these differences. This is a short introduction to the BarcodeTree, an interactive tree visualization for comparing hierarchical structure and node attribute values among multiple hierarchies. Thank you for watching our video.